to go over the Chapter 10 quiz. So for this class, for this year, we're not going to be doing the quiz for a grade. We're going to actually do it in groups. So you get a chance to practice the button pushing and making sure, hopefully, you understand how the re-expression kind of process works. So again, I've got all of my data values in here, and I know the table given to you shows you the kind of 4 columns. So it's 2 with the lengths and the weights. So I am deciding the length of an alligator is going to predict the alligator's weight. All right, so I've typed them all in. So I need to make sure to do my diagnostic on. So if you haven't done that, take that moment to do it. And I'm going to go ahead and see if I'm ready to, or what happens when I make the scatter plot for this. So I'm going to do zoom. Oh, did I turn it on? Come on, turn it on. There we go. Okay, now zoom 9. All right, and so it says right here, find the equation. So I'm going to go ahead and find the equation right now because it's asking me to kind of do it just to get practice with it. So I'm going to find the equation. So hit stat calc number 8. All right, and so my equation is going to be that the weight hat, so weight hat is equal to negative 393.26 plus 5.90 times the length. All right, and it says explain in this context what the slope means. So this means that for each additional, let's see, it's in inches. So each additional inch the alligator is in length, I expect the weight to go up by approximately 5.9 pounds. So almost 6 pounds. All right, so that's what it means in terms of the interpreting the slope. Is it appropriate to use this linear regression model? A couple things here. If I go to my graph right now, all right, I actually would think this, it looks strong, it looks positive. I'm not sure this is linear though. I see what looks like a little bit of a curve or a bend. We've run the regression, so let's check the residuals plot to see if that gives us kind of more idea into what's going on here. So I'm gonna hit second list number 7 and see what the residuals plot shows me. And it looks like there's a pattern here, kind of a little bit of a curve with some few over here to the right, but we definitely seem to have a pattern. And again, I don't really think this is linear when I did the original scatter plot. So I'm going to do some re-expression. All right, so if I go through the process, the first one to do is to square my y values. So this one's going to be second L2 squared. All right, so let's see what happens when I graph that in my scatter plot, my x being the same, but my y being L3. Let's see what this looks like. Okay, that makes it almost even more of a curve, so I'm not going to go with that. Let's try doing, the next one is the square root. So I'm going to go over to list 4 and do the square root of list 2. All right, so let's graph now with the square root to see if that helps. So now I need to change my y to be list 4. Okay, it's looking a little bit better, right? I can see the bend is still kind of there, but it's looking a lot better. I'd be okay if you wanted to use this one for the re-expression because it's getting a little bit better. But I'm going to keep going to the next one, which is the logarithm. So I'm going to take the logarithm of my y values. So I'm going to do the log of L2. All right, and graph those and see if this is any better than the square root. Square root looked a lot better. All right, so this is L5. Let's see what looks here. Okay, that looks even better. So I'm going to stick with this one, the log of my weight versus the length. All right, so let me just answer C since I kind of already did it. So is it appropriate? I would say no, right? This is for the original because I'm just going to say because the form for the original scatter plot is not linear. All right, I think it was distinctly curved. Okay, so let's go a re-expression here. So I'm going to go with this one, the log. All right, so I'm going to do stat, and then I'm going to do a linear regression number 8, and I'm going to put this with L5, my log 1, and I'm going to put my regression equation to Y1. So vars, Y vars, and then Y1. All right, so calculate. So I'm going to write it down. So I'm going to write down the log of weight hat equals 0.580 plus my slope is 0.015 times the length. Okay, so now again, I'm going to explain why my new model is better. So I'm going to say the scatter plot is now linear, so that's good. Let's check the residuals real quick. So I'm going to go to stat plot and compare the residuals here. So second list and then number 7 for the residuals. Let's see what that looks like. Hoping for no pattern. Oh, I forgot to do the y equals. My bad. Let me get that taken care of. So get that to go away. Here we go. So zoom 9. All right, that looks a lot better in terms of my pattern. It looks like more like a cloud, so that's good. All right, so I'm going to say, and the residuals plot shows no pattern. All right, so it leads us to this last question. Use the new model to predict the weight of an alligator that's 75 inches long. So I'm going to do log of weight hat equals 0. I know I'm writing the rounded numbers, but the calculator will not do that, times 75 inches. All right, so let's type in second quit. So we have y equals, or I should say hit vars, and the y1 contains my function. So y1 of 75. All right, so again, remember, this is not the actual weight. This is the log of the weight that's predicted equals 1.733. So like I did, if you watched my classwork example number 2, I'm going to think of this as log base 10. And so I'm going to swoop 10 to this power equals the weight. So I'm going to do 10 to the 1.733 power equals my predicted weight. So let's do that in the calculator. So 10 to the 1 that power equals 54 point, let's say 0.1. So 54.1 pounds is the predicted weight for this model for an alligator that's 75 inches long. Okay, so again, hopefully you had a chance to watch this. You'll be doing this in class with a group of students to make sure you understand kind of the process of re-expression.